Welcome to the Introduction to Proc Reg in SAS tutorial. In this tutorial you will learn how to run regression in SAS. The procedure is very simple, however you just need to pay attention to the syntax. Now, I've already imported data into SAS and I'm going to use the forest dataset which I've used in previous tutorials. If you need to know how to import data into SAS, please go back and look at the Introduction to Importing Data into SAS tutorial. Alright, to start I'm going to use Proc Reg. That is the procedure that you would use for regression, and that's what it stands for, is regression. The data set that I'm going to use is forest. Remember to put a semicolon at the end of every line. The second line I have what's called a model statement, which comes in handy later if you take other classes or you want to do more advanced analyses. But for us, we're going to stick with a simple one. We're using the forest data set and we wish to relate the height of a tree, put an equal sign, so the height is the dependent variable. On the other side of the equal sign, on the right side of the equal sign, you put the independent variable, which is the diameter breast height. Then put a semicolon. After that, put run, and that's all the code you need in order to run a simple linear regression. Go up to the submit button, which is the little running guy, and if you click on that, your output comes out in the output window. Now, the output window has lots of information in it, so you'll need to keep track of all of these pieces of information. First off, you want to look at the number of observations read and the number of observations used. Make sure that those two are the same unless you have some variables at which you know there are missing values. You want to make sure that SAS is using all of your data and using your data appropriately. If you come down, you'll see an ANOVA table, and if you scroll over to the right here, you'll see that there is a p-value associated with the general linear hypothesis. This p-value here is associated with the general linear hypothesis. If you don't know what that means, don't worry about it. Also here, you get the r squared and an adjusted r squared. R squared is the proportion of the variance explained by the regression equation, and the adjusted r squared is a penalized version of that for model selection or model comparison. Down below, you get parameter estimates. So here we have the variable. Notice every regression line has an intercept term. Here's the parameter estimate of 19.33. It gives the standard error of the estimate, which is 1.81. The t-statistic, or the t-value, which is testing that beta 0 is equal to 0. And the p-value associated with that. Here it's 0.001. Now, this would mean, since the p-value is very small, this would mean that this is significant. However, most of the times, we're not interested in the intercept. Most of the time, we're interested in the slope. And that is the slope associated with the diameter breast height. Here is the parameter estimate, 4.39. Here's the standard error, 0.175. The t-value is 25.08. And the p-value is 0.0001, which means that that is a significant relationship. It's testing whether beta 1 is equal to 0. So from this, we can estimate the regression line using the parameter estimates, and we can also test to see if the regression equation, or there is a relationship between diameter breast height and the height of the tree, as well as get some information on how good our model is. How well does it fit using r squared? Well, that is the end of this tutorial. If you have any other questions, please ask or watch this tutorial again.